Hi everyone, welcome to Leetcode Weekly Contest 376. Wish me luck. Oh, that loaded very fast today. One special move. This seems kind of difficult. You want the, obviously you don't apply the operation more than once per element. Okay, I think I know how to do that, but I think that's not easy. Choose any and increase or decrease by 1. Okay. This contest seems kind of hard, to be honest. Sure, I might need to do a bit of working out on paper. Is that correct? I don't think that's... Oh no, that seems about right. Okay, and then... Wow. I guess well current is given the K. Something like that, but I just need to figure out what this is. I think that's roughly correct. No. Oh, I forgot to sort. Okay, we're going to treat that as correct. To me, it is this question which is much harder. Yeah, this question is kind of difficult in my eyes, but I think I can do it. I hope Python doesn't tell me on me. If it's less than 10 to the power of 9, that means I'm going to do computation out here. Okay, S plus. I'm trying to generate all palindromes if you can't tell. I guess 1 onwards. Then sort. I'm just going to print the first like 200 palindromes just to double check. Yeah, that looks roughly right. I just like, yeah. Sure. These nums, I guess. I'm just going to get the median element. And then we're going to get B is, I don't remember the syntax. Is it like bisects left? Oh, X. If A is less than 0 or A is greater, then 18. Return min and FFB take 1. 6, 11, 22. That roughly looks correct, but I also just want to that looks wrong. Again, I'm just going to print out the last few ones. Yeah, so this is 10 to the power of 9 minus 1, right? So the answer should be 1, not 9,000,001. Let me just say number of palindromes less than 1 billion. 109989. Oh, so I'm generating palindromes wrong. That doesn't look right. Yeah, apparently I'm generating palindromes wrong. Oh, okay. Yeah, I don't know what's wrong. Am I missing cases? I feel like I'm missing. I don't know whether this is correct though. Okay, my brain isn't working. Oh, okay. That's because I'm dumb. This should be 10 to the power of 5. And then while L is greater than or equal to L of hub. There, that's better. Okay, that should be correct now. Divide the array into arrays of size 3. Every element is in one array. I feel like you greedily divide it, like... Okay, I'm just gonna submit these two. AC, alright. For iron range, I guess the length of numbers divided by 3. C0 is greater than K, and then we return the empty array. Always all append C. AC. Sure. Two, 4, 9, 5. Alright. That's all the problems done, but that was pretty slow. Um, 1408. I'm just gonna go check Leetcode China to see how many people beat me. Okay, nobody there has finished, according to the site at least, which means I might have won, but I can't tell. Okay, I'm gonna go through the solutions. This contest was actually quite hard, and question 3 especially took me a bit of debugging. Okay, this question is fairly straightforward. I just create a frequency array. So for each element, how many times does it appear? I can do this in Python. Like, this chain allows me to, I guess, it basically allows me to flatten flatten the 2D array into a 1D array, and the counter like creates a frequency array over it. Then I just loop over all elements, and if its frequency is 2, then it's the first element in the answer, and if its frequency is 0, then it's the second element in the answer. Fairly straightforward. You can also just directly like count it because the constraints are so low, but this is easier for me. Okay, this question is, I guess the observation is that you always want to just sort it and then like sort it and group it into threes naively. That's always optimal. Why is it optimal? Well, let's say like our array is like this, up to n, and let's just assume this is sorted for now. The thing is like, A1 and A2, like of all the groups of three, of all of the groups of three, at least one group contains an element greater than A2 or an element less than A1. Because whichever group has A1, like, will also definitely contain an element which is greater than or equal to A2, which means that this difference, like, the answer must be at least the difference between A2 and A1. Like, there's no way around it. And same for A2 and A3, whichever group has A2 in it must also definitely have an element which is greater than or equal to A3, which means A3 take A2 must be like the answer must be at least A3 take A2. And now for A4 take A3, there's no requirement because we could just take this as one group and this is another group, and then A4 take A3 kind of doesn't appear in any like none of the intervals will contain a number greater than A4 and a number less than or equal to A3. And so on and so forth. So for A4 and A5, for example, there will definitely be a list. There will be a group somewhere with elements less than or equal to A4 and an element greater than or equal to A5. I think you can prove that fairly easily. Because one of these elements certainly must be in a group with something bigger. Because this isn't a multiple of 3. And I don't know how much my explanation makes sense, but basically, if you take this list, like there's a pattern that like these two elements, like the answer is bounded by these two elements, the answer is bounded by these two elements, but it's not bounded by these two elements. And as it turns out, that means it's actually just optimal just to group them in threes like this, because if the answer is always bound by these differences, then why not just put them in the same array? And so on. I don't know how much. And now that I think about that, yeah, I don't know. That's just my thoughts, at least. Like, I'm not actually sure if that's correct now that I think about it, because I forgot about A3 take A1 difference. I think I stand by what I said, but slightly different. I think what I mean to say is there's definitely a group that has an element less than or equal to A1 and an element greater than or equal to A3. There's definitely a group that has an element less than or equal to A4 and an element greater than or equal to A6, and so on. Yes, that's what I mean. Sorry. Ignore what I said about adjacent elements. It's really these extremal elements. Because, yeah, it's impossible for every group with, yeah. Like, there's definitely some group which contains an element in this prefix and also an element in this suffix, because it's impossible to divide this evenly into 3 or this evenly into 3s. And so you might as well group these into like, you might as well do this grouping because the element's bounded by these differences anyway. And so, yeah, I don't know, the implementation is very straightforward. You just sort it, take the groups. If the group range is too big, you return it's impossible, otherwise you take the current group. Sorry if that didn't make sense. If that didn't make sense, you can write a comment and I'll try to explain more. But hopefully that made some semblance of sense. Okay. Now, interestingly enough, questions 3 and questions 4 were both kind of similar, actually. Okay, first let's make some observations. If we apply the operation multiple times on the same element, it's always just optimal just to apply it at most once per element. That's because you'd never take an element, set it to some number, and then set it to another number. You would just directly change it to the final number, and that's because of this absolute value. That's always better. You can prove it more formally by the triangle inequality. And that, yeah, so basically the question is just pick a number, pick a palindromic number y that minimizes the sum of the absolute differences between each element and y. Okay, let's do a related problem. So a related problem is we have some array x1, x2, x3 up to xn. And let's just assume this is sorted for now. And then let's reduce the constraint that y is palindromic. Let's just say y is any number. And let's say we're asked to pick a y that pick y that minimizes, I guess, the sum of the absolute differences between each element and y. Now, it turns out that like it's optimal y is the median. To see why, like if for example, if the list has an odd length like this, if you choose, and keep in mind this is sorted, right? If you choose y equals the median, so x4, if you increase y by 1, then I guess the distances from y to these elements increases by 1, and the distance from y to these elements decreases by 1. But because there's more elements on this side than this side, in total the distance kind of increases. And so in some sense, the further y away is from the median, the greater this sum gets. And the same is true as if y decreases less than x4. You can show that, so you can show that x4 is optimal. In the case that, very similarly, in the case that the array has even length, the optimal y is anywhere between, I guess, the two middle elements. Because if you move y, if you increase or decrease y like within x4 to x5, like let's say y is somewhere in between there and you increase it by 1, then these distances decrease by 1 and these distances increase by 1. So this net zero change to the distance. So anything in this range is optimal. And then same as before, if y moves too far outside, like past x5 or below x3, the distances will increase for the same reason. So actually it turns out that this code just kind of generates all palindromes. I got a bit hung up because I accidentally didn't have enough zeros. And I just Googled the number of palindromes to check that I was generating all palindromes. The way I generate all palindromes is I generate all possible halves, I guess like the first half of the palindrome. And either I concatenate it with its reverse or I concatenate it with its reverse with the first character chopped up. And this gives me all even length palindromes, this gives me all odd length palindromes. And then I just sort it and remove the ones which are greater than or equal to 10 to the power of 9. Anyway, so now that I've generated the list of palindromes, it's actually fairly straightforward. Now we, like, because we want y to be in the median, like, it turns out that we can just pick one of these middle elements, get the first palindromic y greater than or equal to it, and get the first palindromic y less than it. And those are the only candidates of y that we need to test, because the further away from the median, the worse the distance gets. So all I do here is I just sort the elements, get the median element, and perform a binary search on this list of palindromes to find the first palindrome which is greater than or equal to x. And then I only consider that as a candidate, or the element 1, or the palindrome 1 position below it, because that gives me the palindromes on either side of the median. And then I just test it naively, because there's only 2 to consider. So hopefully that makes sense. This is like a order n log n. Another trick in Leetcode, like if you in Python at least, if you write code outside here, it only gets executed once. So I only generate this list of palindromes once, which is a trick. Okay, this question is actually extremely similar. So it's again about this median trick. So let's say nums, let's say the sorted version of nums. Oh, actually, let's just consider an array in general. Let's say we have an array. Let's say up to an. And let's say we want all of these elements to be the same. So I guess the min cost to make all elements the same, well, it's actually just the same as this question, right? Because if we pick y as the final element, then what we're trying to minimize is this sum of absolute distances again. For the same reason as before, we we're just minimizing the sum, and therefore it's optimal to choose y as the median. And so basically, this kind of gives rise. Yeah, y is the median. So I guess we can just first let's just sort nums. So if once we've sorted nums, the question now becomes, I guess, what is the longest subarray of nums which can be made equal in at most k moves? And we can just use a two-pointer algorithm on it. And that's because, I guess, if subarray 1 is contained within subarray 2, and subarray 2 is doable within at most k moves, then subarray 1 definitely is as well. That means we can use the two-pointer algorithm. So I guess the final question we have to do is we kind of have to maintain this optimal sum. And we want to say that if this sum is too big, we should contract, I guess, while the sum is too big, we contract the left endpoint. The question is how do we maintain, I guess, the sum of all elements to the medians? I guess, like, how do we maintain, we want to maintain current, which is, I guess, the fewest moves to make all elements in the current subarray equal. Now, it's actually not that complicated. Like, here's an example array. And let's say I extend the right endpoint by 1. So I want to add 9 to the back of this subarray. How does the answer change? It turns out that the answer just changes by the difference of 9 and the middle element. Because if we treat 6, because when we have this subarray, choosing y equals 6 would be optimal, right? Because 6 is the median. And when we add 9, y equals 6 is still optimal. So the answer, so we don't change the value. We can kind of think as the y as being the same for both this subarray of length 5 and this subarray of length 6. And so the answer just increases by 9 minus 6. And now what happens if this had an even length and I added another element in? Then it turns out that actually it's kind of this, the answer just increases by the difference between this one and this element here. And once again, you can consider this because in this subarray of length 6, it's optimal to choose y as like somewhere between these two middle elements. And I can pick, right? Because anywhere between 6 and 7, choosing y would give the same optimal cost. So I just pretend, let's just imagine that I choose y as the rightmost middle element, y equals 7. Then when I add in the 10, choosing y equals 7 is still optimal. So in either case, whether this has even or odd length before, the sum just increases by the difference between the rightmost element and I guess this left midpoint of the whole thing. And by the same reasoning, I won't walk through the whole thing again, but if we contract the left endpoint, the distance just decreases by the difference between the right middle element and the leftmost element that we're trying to delete. It's symmetrical. So this is how you can kind of update this sum in order 1 time. There's faster ways you can use like a segment tree and do all sorts of stuff, but this is definitely the simplest way. Okay, I have also developed, I wrote one problem. If you want the link, it's here. It's get out of the context 6.5, no more coyotes. And this uses this median trick and updating these distances efficiently like this. So I've used this trick before in my own problem, which is why I knew it instantly. If you want to try this problem, you can. It's slightly difficult, but I think it's a good problem. Okay, now that I've gone through the solutions, let's just check what my rank is. Oh, I got beaten. So, okay, so I got 2nd place on Leetcode US. And did anyone from China beat me as well? No, so China was very slow. So I guess I got 2nd place overall. That isn't too bad, but it does leave me slightly short of my goal. So my current rating is 3,638. And Neil's is like 3,686, which means I am like 48 points from him or something. And a win would have given me enough points to overtake him. But because I got second place, I don't think I'll reach him. I think I'll be like 16 points behind. So I guess it'll be one more contest until I can overtake him. Anyway, wow, we had the exact same submission times. Almost identical. What the heck? Except he'd already done these ones as well. Anyway, thank you so much for watching, and I'll hopefully see you guys next week.